Now, Joe and I had a long conversation about this upcoming, maybe possibly as early as next year, 90 Spitfire that Dave Downey is helping us along with. And I wanted to, yeah, it dawned on me in the middle of the conversation, something very significant had happened in the last 10 years. And I thought I'd put a minute or two of storyboard on here. Maybe this has happened to you too. Now, it may seem, it could seem like, well, you know, what's the big deal? It was 1996. We made the first Spitfire. 2006, it's now 10 years later. 10 years. And what's really changed for both Joe and I, and maybe for you too? Well, the first thing was the design. Those original Spitfires, the original 3, were made with almost stock Pattern Master airfoils, and I think they work pretty well, along with a lot of other planes. But our new, and I'm just going to use the 10-year down the road, we're going to call it the 10-year Spitfire. It has a B-25 airfoil. Now, we know from building 3 bombers, that's a pretty efficient airfoil. It'll let us carry a lot more weight efficiently. It's a low drag airfoil. It's from the, I should say, the pen of Dave Downey. But already looking at this, there's a significant difference. It's not like you pick apples and apples. It really is apples and oranges. Well, let's start here. We had the best motor of the day was the faithful, reliable Tiger 60. And that was about as good as it got back then. And right now, quite a difference. 50% difference in displacement, easily double a horsepower. But see, already we're starting out with, it's Spitfire and Spitfire, but it's not exactly the same. And some of the things that are significant, when you have to make a list to kind of figure out why they're so significant and how they got to be so significant. The finish. What we had back then was Sig Dope. And that could be, at times, very slow drying, chewing gummy, hard to sand. And what we have now is Brodak Dope. Quite an improvement in my prejudiced opinion. But now you're looking every step of the way, it's not gotten better, it's gotten a lot better. Tons better. Some of the things that have gotten, well, these are the things that are hard to evaluate. The trim. Years ago, we had a good basic knowledge of trim, but now it's super trim. We're 10 years further along in our education. And so, well, if you look at this list, and the way this list evolved is I was talking to Joe over the phone and I'm saying this got better, that got better, this got better, that. You don't even realize it until you make a list. Every step of the way, this has gotten better. The only thing we haven't figured out is how to get somebody else to answer the telephone. Let me get the phone. Let me get back here. That phone rings off the hook this time of year. Here's the other point I was trying to make. 10 years ago, semi-scale. It was limited somewhat by the amount of horsepower, the size, the diameter props. There weren't many motors back in 1996 that would turn a 14-inch 4-blade prop. So if you made a Bearcat or a Spitfire that had a big P-51, you were limited. You were really limited in the world of semi-scale, and also how big and wide you could make the fuselage. Because the engine just, I remember guys with Tiger 60s with, you know, just a little stub sticking out of the spinner on a scale plane. Well, now I think you can build what you want. Okay. Karen's home. But this is what I wanted to make my point. The people, the legends of the event like Al Raby were also limited by the motors of the day and how much horsepower they made and how reliable they were. On the other hand, the future that's just around the corner, we're not limited at all. Big 4-bladed props, scale props, big 3 blades, big 2 blades. And the amount of designs that you can make in a semi-scale mode, and this is the whole point. 10 years ago, it was like going to Woolworths. Nowadays you go and it's like going to Walmart. There's just no, Home Depot. There's just no limit to what, if you can dream it, you can probably build it. And that's in thanks to all of the advancements in the sport in the last 10 years. Now, and of course, it gets even better than that, because if you decide, hey, I like the nostalgic look and feel of the old Tiger 60, and I like the old designs, the designs with the big inner wing and everything, thin airfoils, you build nostalgia planes, and thanks to Mike Cavell and VSC, there's a place for you to even where the appreciation for that is very high. But in the meantime, it gives you the choice of building anything you can dream. And having said that, I know Joe Adamusco and I know Dave Downey, they're already dreaming. Now, on the end of the last DVD, I tried to explain what I wanted to accomplish here. And I made up some test parts, just fooling around. Late at night, and I had a little bit of time to play. So what I made up is what amounts to be a half a horn, and I also cut up a couple other horns to see how practical this was going to be, because I need to invent or make some way of confining that in the other side of the horn, and I need to make it as bulletproof as possible. I need to get the width out to about 3.5, so I need to make this sided horn a custom piece. Now what I did, I took a piece of our horn material and I laid out where this would be the pivot point. Until I actually make this up, I'm not going to know how many times I have to go back and make it up for sure. This is backwards as I go on and on. So let's flip it, because this is going to be the outer piece of the horn. So what's going to happen is the inner piece is going to rotate, and this is going to be a little bit of a sliding operation here, but this faces down. Then up here I'll do the traditional holes, and this is the normal spacing we always use, and solder in bushings up here. And then what I'm anticipating is I need to figure out how I'm going to do that pivot, and up here a 632 bolt, and just make micro fine little adjustments in this. The problem is I want this to be, if you look at the end of the last tape, you'll see this was the problem with the old systems. But what I need to do is just look at this for the next couple of sessions that I'm working, and make up some prototype parts, cut up some horns, get a feel for how I want to do this. And I'm not sure how I want to do it yet, but I know if I have enough prototype parts in my hands and I can make up some bent wires, I need to figure out how I want to do that bushing. I think in the end I'll really have something that's a lot better than the part that's on the Testarossa. And the part on the Testarossa was just, it worked, but it was just a nuisance to use and very dangerous about putting a hole in a plane or a dent. And the next step is I wanted to drill all the appropriate holes here. I lined up a piece of the material we use to make custom horns. I wanted to drill this out. Anytime I'm making a prototype piece, I kind of like to dry fit it out before I go any further. Try to picture in my mind what that's going to look like. Some of these fits have to be relatively good. The bushed ones, I have bushings for there. Again, it's a prototype part. We're trying to upgrade something that we had in the past, and we're going to find out once we finish the part if it's practical to make them this way. One of the things that'll make this job a little more accurate, a little easier, is just by using a starter drill, because I want these holes to be relatively precision. I want them to be in good alignment. I don't want to have them offset. Now I know there's all kinds of theories about having these offset angles and things, but the problem is with all that stuff, over the years I've gotten used to having the system that we have in the plane now, and I'd have to, I'm not sure until I try one. And Joe Adamusco seems like he wants to try one in the Spitz, but Until then, we're going to try to go with the tried and proven stuff that we've used over the years. And you can see what that does. All it does is put a little spot. It's not made to drill a hole, just a spot that the drill will get a nice fresh start when you go in. And this way you get, I think you get a lot more precision than when a drill is out there and it's wandering and walking around. It's another little thought. Anytime you make a horn upright, leave it on the piece of material, drill all the holes first. It just gives you a handle to hold it on. Just makes making it a little bit easier. If you look back over the videos years ago when we were making production runs of these in George's shop, it really gets to be labor intensive. Oh, I hear the phone ringing. Now it's funny, that was Rich on the phone and he's dying to work on a Stuka, but we got so many things going on here in the shop at the same time. Right now we just can't break away. Anyway, these are really, once you get used to using these to start holes, you really wind up wondering how you ever lived without it. I want to make sure that the holes I drill are very precision, because I'm going to be putting bushings in these holes too, of course. And I need to figure out, again, on any prototype, I need to figure out exactly, sounds like it would be real easy to figure this out, but until you actually mock up a part, you don't know if this is going to do exactly what I want to do, or if it's going to have problems staying in alignment or what. And until I make it up, I'm just a little uneasy about figuring it out. And if I have to go back and do it over right now, it's not a problem. I don't want to make the whole part, install it in a plane, and then realize, like last year, that, ooh, that's going to be hard to get at the screw. Once you make that mistake and it's in a plane, it's a lot easier to figure it out now. You can see what happens once you have those starter holes. It's very easy to maintain the alignment. And once I get all holes drilled, I like to get the burrs off of them. And I need to get out a hacksaw, hacksaw this part off, grind it smooth, and then see if this is going to be, if this is going to evolve into one of the parts. Or again, whenever it's a prototype, there's this time when you just have to you have to start somewhere and then see, is it too big, too small, too long, too short, but you got to start somewhere. Got those just rough the radiuses on the end. Now the first test fit we need to do here is, I need to get this to be a precision fit. And of course there's a little bit of solder on here. I'll just take a little piece of sandpaper and just get this that I can get a nice, I want almost a press fit. I don't need a bushing fit. I just need to get that fits right in there, a nice snug fit. Okay, now that fit is nice and tight. That's about as tight as you can get. But I'm going to have to establish a little bushing in there because these parts have to slide. Now remember, this has to slide back and forth, so what I need to do now, it's such a nice tight fit, I need to elongate one side of this so that the part, when it's got the 632 bolt, can do a little bit of this scissor action. And the problem I had in the beginning of this is I thought what would have to happen is this would have to go 10 degrees or 20 degrees. Well, if it's that bad, we're going to drive over the plane with a car anyway. What I want is micro fine adjustments, and I don't want them from tweaking. When you tweak a horn, a month later, a year later, it starts creeping back. Wire has a memory. The idea of this is to eliminate all the wire memory, at least in theory anyway. Anyway, next thing I gotta do is make this elongated slot so that I have, and the part that's missing on the one on the Testarossa is this bushing. This bushing was never, I just had two flats and I used this to be the bushing. Yes, and it worked. To be honest, it worked, but it just, I never slept well at night knowing that there was a time bomb in there. And this part of the horn will be the normal part with the bushings, with the normal ratios that we've become accustomed to over the years. I don't want to reinvent any of these ratios. They seem, once I'm comfortable with them, I don't want to start reinventing anything. Now I'm able to just get a little bit of, and I think that's going to be enough movement for right now. Now before I cut and bend the wire, I want to make sure I'm on center line with this part. I need a little bit of clearance for the edge of the flap. So I basically need a piece of wire with that bend in it, and then I need to set up the torch and the silver braze and braze my wire in there. Now the trick. I want to lay this out in full size. It doesn't matter if the horn is right exactly on center. Oop, as he drops it. Well, I don't need the upright. It's the wire part I need. In fact, I can lay it out backwards. It wouldn't even matter. Okay, that's going to give me just enough clearance. See, what I don't want to have is that the flap is rubbing up on here. I can make the little insert with balsa wood and or make a fillet, but I don't want that. I don't want to have this at the end of this whole operation that it's right up on the body like that. This looks like it's okay. So now the next thing is this is going to be going, and I got to make sure I don't put this on backwards. This is going outward. This is going upward. And I want to try to get it as close to 90 as I can and get a silver braze joint on there. So this is the material we use to do a horn joint. This is 45% silver brazing alloy. You need to have a torch to do this. A soldering iron won't melt it. This is the flux. You need to have the flux, and it needs to be, it dries out. When it dries out, you put a few drops of water in it. That's assuming you can get the top open. What happens, it dries out, you put a few drops of water and stir it up. And this is what the material looks like, and it is, a roll like this is about $150 now, so you really just don't use this indiscriminately, but you need to get just a little bit to get a nice joint, and you'll use the heat to pull it through the joint. And that, when we've done these and used this material, we've literally made thousands of horns and never had a failure. When you use other materials, brazen rod, coat hanger wire, any of the cheaper solders, yeah, you can save money. In a production run you save 20 bucks or something, but then one person in 100 has a failure. This is bulletproof material. Now I learned when I worked in a machine shop how critical it was to have the flux very fluidy like this, because it's got to stick. Now what happens is, when you use the flux properly, at the end of the job there'll be what looks like glass around the joint, and it's that glass that the next day, or there's actually a lot of ways to get it off. You can chip it off, but if you're really doing a production run of a bunch of parts, you just leave it in a bucket of water overnight. It rusts everything a little bit, but that flux then comes right off. But this is one of the keys of getting these, and of course getting the joints perfectly clean. And a real test of doing one of these. Yeah, I see we may have to need a refill on the torch. The idea is to get the solder to melt on one side and then let the heat pull it through onto the other side. There we go. I like to get it as close to 90 as I can. I see our old reliable torches down at the end of the gas. Alright, I see a problem already. Now, I didn't anticipate this, shame on me. I'm going to have, and again, I got a good use for one of these big pliers now. This is the way it always works out. You don't dare touch that now. And I can see that's going to want to tip as the flux. It's a good thing I'm showing this. And of course we need another tank here. But I'm going to have to keep that in mind. You see what's happened is, no way I can counteract this. I can just flip the part over, but I really would like to get it this way. Again, my soldering skills are, now the solder is melted, but I don't have any going through, so now the answer for this is going to be, because I have the heavy part on top, it wants to swing over. Well, if I put the part on the other side, and it seems like that's what I should have done all along, a great solution. Hey, these are magnetized pliers, lucky me. So what I'll do is, and maybe you can use this technology in the future too, have the heavy part sit down, improvise a little bit here. Now I should have the heavy part going down here and I'll be fine. Not realizing these are a magnet, maybe you can use that to hold it down. There we go. All right. Oh, even Jimmy would be impressed with that joint. Is it 90? Yeah, it's close enough. Now, trick is, shut the torch off, let it cool by itself. Don't quick cool it. Let it sit. We'll scrape all the little material that looks like glass on there. Looks like we got it 90. Looks 90. And we got solder to come through the joint. And one of the ways you can tell if you have a decent joint to begin with, just a rough, and I'm certainly not a professional welder or anything like Scott Dinger is, but we got material that's flowed through the joint. Now a lot of times when you're doing a typical horn, with two ends of the wire, you put the solder on one side, heat this side, and let it pull the solder through. But this material, now, very important that this cools. We got a nice joint on there. When that's polished up, That'll look just fine. And we better remember to get some MAP gas. We're down at the end of that. Seems like we're at the end of that tank anyway. Alright, once that cools, we're going to start cleaning it and fitting it up. Now when it cools, that joint's pretty ugly, there's no doubt about it. But you see this glass-like material right here? There it goes, comes right off. And I like to clean and polish these joints. It also lets me, and of course this comes right off with a wire brush. But we do have the solder going right through. That's pretty much guaranteeing us that we have a good joint there. It's not going to fail. Now in cleaning this up, again, one of the tricks you can do if you're not in a rush is just leave it in a bucket of water overnight. But I want to work on this yet today. And so I'm using Brillo, steel wool, anything to get it cleaned up, sandpaper. Because I still need to solder bushings on this, and I still need to make that little pivot bushing. So I want this part to be clean and I just want to inspect everything every step of the way, make sure I don't have a joint that's going to be a problem. Because again, I'm not a professional solder expert or anything. It is certainly, when you get, this is the heart and soul of a stunt ship. And if this part fails, it's a problem. But it does polish up relatively nice. At least we can work on it now. Now I had to grind this flat, but I wanted to show, if you can see it, the braze is right in the whole circumference of the joint, so I have good feeling about that joint. And a lot of people look at this side of the joint and say, oh, is that pretty or not or whatever. Yeah, it's the material in here that I've found really matters, is to get that material to come through on the whole joint. It's one of those things that if you try to make it too pretty instead of structurally correct, and sometimes I guess if you're a professional welder you can have it both ways. Too bad I'm not a professional welder. Now I want this area up here to be clean so I can solder in, and I can use Stay Bright solder to solder in some bushings, the next step. Now from all our time of making control horns, we have several that they're within thousands of each other, but these are undersized, and these are the ones I prefer. Now a lot of people don't. A lot of people want 093 bushings in their horns. I don't. What I want to do is I want to put these bushings in, and then I want to silver solder them in, and they're a press fit. I got to go over to a press and press them in. Once they're pressed in, then I want to silver solder them. And then I want to take a precision drill, an 093 drill, and with a slow speed just ream them out so I have a perfectly tight fit on the wire. If I use the normal ones, they have about 2/1000ths of clearance, and once you solder them, sometimes they're a nuisance to get the fit just right, that you have the controls that just flop back and forth. By the way, if anybody wants any of these bushings, because we have thousands of them, just let me know and I'll send a bunch with next time you order something. No problem at all. Well, one thing we have is plenty of eyelets. Just to give you an idea of how many eyelets we've used when we had the machine shop, we'd buy them by the billion. Literally. There's always a minimum order when you order these things, and over the years I've got several sizes, but the undersized ones are the best for the horns. So if you're ever in need of an eyelet, have no fear. I got the part in a little handheld vise, and I find that real handy. Again, they're in Home Depot, Lowe's, all over the place. Now you notice what I did is I made the joint that has the high temperature first, because if we put the bushings in and then try to solder this part, what would happen is these joints would get loose. So there's like a step A, step B to doing this. And I want to fill all the gaps with solder, and I can polish these off when they're done. Again, each step of the way I've been cleaning it, and I know these are precision holes. They're just a little bit less. I think they're 091 in fact. And on this side you can see that the solder has wicked its way right through. Now when I'm done, I'm going to grind these off flat so that we have a nice surface for this to rub against on the bushing that's going to be on the wire. And I'll go back to the sink and clean that joint up. Now the idea was, or is, I want to make a little relief here. It serves two purposes. What it does, it allows, when this goes in for the final time, it allows some epoxy to get in there and make like a Chinese necklace so this can't slide in and out. It also allows, while we're fitting the flaps on and off, on and off, on and off, it's just easier to get them on because this allows you to bend the flap and line up the hinges. Without that, you're putting a stress on the flap. So I always have done this. Just take a little material, but leave a ball on the end. The ball on the end is the resistance going through the arc. Now I know this is going to be one of the difficult things. See, I have these two little bushings here. Little washers, actually. And I wanted to find, I was wondering if I can get away with using just one. In fact, let's just take a new one out. Hell with it. Since these aren't doing anything, they're just allowing us to have a pivot point, I may be able to get away with just having one. I would have to grind some of that wire away then, although it would be nice if we could do that. And one, I think, would hold it. So the trick is going to be here, get rid of the gloves for a minute. Let's find one of these, because we need to solder. And I want to see right on that pivot point. I have to be real careful I get it right on that point. And the idea here is that that's going to hold that in alignment. When this part keys in, that's going to be my fulcrum. So I'm going to real carefully just solder that right in place. Now this turned out to be trickier than I thought it would. What I did, I held this on one side, soldered one side because I didn't know how I was going to be able to pull that solder through, just holding it with the screwdriver. And what I'm going to have to do when this is done is see if that's going to be enough of a catch for the horn. I can't really tell if I'm going to be happy with this until I put the bolt in place. I still have a lot of material. I'm going to grind some of this extra little sprue off, because I need that to be, when this bolt is tightened, that can never come loose. Even though these bushings are holding it in place, I really don't want to have that as, as the defining thing here. And if I have to, if I'm not happy with it, I can just simply add another washer there. Just put two washers. In fact, maybe that looks like it would be the right thing to do right now. So I can always take or add or take a washer away here. I guess I shouldn't panic about that. To make that solid. The trick here is going to be to line this up. This is rocking around like James Taylor here. Okay, put that on there. I think part of what you can get from watching this is maybe that things don't go right. A little part like this, and people don't believe this. I once made something similar to this for a customer. I don't remember who it was, but I remember spending a whole day. And basically the agreement was, I want it, money's no object. Okay, well, we always like to work when money's no object, that's for sure. But then when I gave him the bill for $300 for a control horn, alright, let's see if we can in all my dexterity. This looks real easy when you see it done, but it isn't. It's easy to just tack one side. Now it's critical to get, as I'm doing this cleanup operation, get all of the solder out from inside the bushing so that side of the horn can sit down as far as possible. And I've tried several Dremel tools without really good results. Number 11 blade has given me a lot better results. Now I know, as I assemble this, and by the way, this is going to be a whole day working on this, I know I can see how much material I have before I hit. So I want to see that be a tight fit before I stop scraping material away. And that's going to, I hope, give me what I want once I put the bolt in. Because if this is a sloppy fit, nothing good is going to happen. Now the last step is I put the 632 bolt through the blind nut, and I want to just tack solder this in place just to keep it from loosening up. Even though we'll have a hatch and we'll be able to get in there, I actually could do this with an ordinary nut, but I think this is a better choice just to hold that in place. Now just the final polishing here after we get done with all the fitting, the bolt, the blind nuts soldered in. I want to remove as much extra material as I can without weakening it. I assume this is going to be a quarter ounce or so heavier than a standard horn, but having the reliability of that adjustment instead of all these tweaks and tabs, and I think somewhere down the road this is going to pay. And it's going to pay big time. Because the 632 bolt is not going to loosen up. It's not going to strip. I'm going to have a hatch on the bottom somewhere. And I checked the rotation. I have about, maybe 10 degrees of rotation on each flap. And I'll never lose, the main thing is I'll never lose neutral on the middle flap. When you tweak something, you'll lose neutral. Well, this is going to maintain neutral at all costs, and the only one I'll ever have an adjustment in is the outer flap. I took a little material off the bottom. And one of the things I love is when I'm done with a job, just hanging up the tools on those magnets, those Warren Walker magnets. Boy, they nice. You work with a tool, whatever you got to do, boom. What a great addition to a shop. Thank you, Warren Walker. We spent quite a bit of time on making this part. In fact, it was a whole session. But I think the end results, it's going to give us an option that we didn't have on other planes, a reliable way of adjusting the flaps without inducing a memory into the wire. And I hope it's going to really be, believe me, if somebody wanted a part like this, and by the way, I want to put a little plug in here for Tom Morris. Tom Morris is still making custom horns. So if you want a custom horn, what you do is you send Tom Morris this DVD, tell him to make one exactly like that. And if he's mass producing these and making, 100 of them at a time, he can make these, reasonable cost. Now, I can't. For me to make this, it's a whole work day. Every part is carved and handmade, and it's a whole different ballgame. Now, I'm just hoping, if this works out as well as I think it will, and I have no reason to think this is a giant upgrade over the Testarossa part and the Spitfire part. And the best thing of all, the best adjustable horn we'll ever have is if we don't ever have to adjust it. But because of the 90, moving the CG, moving things around on this very experimental plane, I really didn't want to take a chance that this is going to be one of these planes where we're tweaking things and they bending back and putting tabs on, and hopefully this will help eliminate that whole part of it. And that was quite a day's work, but I think in the end, well, next time we get to do a session we're going to install this, but right now it's time to hit the molds. Now today we have a very rare opportunity. This is the rarest of rare opportunities around the holidays. Karen has a meeting at work, so I have an extra session tonight. And I've decided maybe I can get that horn on the back of the wing, get the controls hooked up. That would be very nice, but we've been working on our Christmas table every day. And these are things she made. She actually made these years ago. Every year we set them up and we go back to being children, and I love it. Look at the dolls on the table. Hard to believe, huh? Well, for anybody that's got to deal with having dolls at their dinner table, I guess it could be a lot worse. And as soon as that coffee's done, I'll be headed down to the shop for another. This actually, taking advantage of this really cold weather. I don't know about you, but I love having a nice place setting as we come up on the holidays here. It reminds me how in years gone by we used to set up that gigantic village, and we had a 14-by-6 village. And as we're getting older, we just don't have the energy for it anymore. Now once I'm done with this coffee, we're going to jump right on this, because again, I like to always take advantage of time, not normal shop time. It's just if I can sneak in a little extra at night, a little extra in the morning, seems like I get a lot done. Next step is to get this horn put in place. Make up the bushings, lay it out. Now it's a little bit off center on purpose. I want it to have, and I'll mark the center of the wing, of course, not the center of the horn. This is offset to one side for obvious reasons, is because I wanted the adjuster right in the middle. I didn't want the adjuster off to the side of the body. So before we even start here, let me lay this out. Because if things go well, we'll even get the pushrod hooked up tonight, get the bushings on the horn. We can lay this out in full scale. So the first thing I need to do, well, let me do this on a storyboard. The first thing I need to do is establish that we're putting the horn right in the right side of the body. First thing I did was double check, and believe me, many times I'd do something and the next morning come by, try it, and it wouldn't fit because I didn't check it. Now I checked it onto the fuselage so I have enough clearance on each side as the first step of this project. And so the first step is figure out the total distance, and it's going to be 1.7 off center. Now what we're concerned with most of all is that the horn, the legs are equally spaced off what is now our center line. So now that we know the spacing, we need to figure out exactly where our notch and the trailing edge is going to go, based on it's going to be to the center and it's going to be off here. So pretty much this is where we're going to have to take our notch out so we can get a zona saw and just take that notch out to start our alignment. Now because we need clearance on both sides of this, and I want to make sure it's centered, I want to make sure I have this enough clearance, plenty up, plenty down. And this little sanding block that Les made looks like it'll be just about the right size. Get in there and dress that notch off. seal the edges with CA so no, if any fuel or anything gets in there, it's not going to start puckering up the wood. Now, one of the little things, I made these little bushings up. I went over and weighed the horn. The horn is 4 grams more than a traditional horn with the same width. So the 1/8 of an ounce that we're losing here, I'm not going to lose any sleep at all over it, having that bulletproof adjustment. Now, a lot of times when you pinch these together, and I'm a believer of, years ago I tried to put brass tubing in here, and what would happen is if one drop of CA got in there, boy, what a mess. So as a safety thing, I always use little pieces that have a little, I don't know what you would call it, a little escape route. Now, if for some reason either epoxy or whatever gets in there, and you have then made a no movable horn, trick is hold a soldering iron to the wire and just apply pressure until it loosens up, and then put a drop of chain lube on each side and repeat the same thing. The heat wicks the chain lube in there. Now, whenever you squeeze these, here's another little tip. See it? They're always like a little butterfly. Let me put this up here. They never get to where they're nice and tight. Well, the trick is take a piece of wire. It's really not even critical what diameter it is. Put the wire down all the way in there and do the last little bit of squeezing. And by doing that, now when you squeeze it with the pliers, and boy, again, a nice little, these little pliers that I bought in Costco for 16 pairs for $16 have really paid big dividends. Now you get a nice flat edge where they'll fit right into the trailing edge, as opposed to a butterfly where you have to squeeze it down. Okay, next thing is to mark and lay out. You got to put 2 little slots in here to confine these, and I like to get these as close to the upright as possible. When I put them out here, the problem is then the horn starts sliding around. I want these to be a side load and a front to back load, both at the same time. Now on this wing type, because we have a center line, it's real easy to figure out, but I would want to make sure also, if you were doing some other type of construction, that you were right on the center line. You don't want this to be in a different plane than the hinge, the row of hinges. That's an easy way to put it. Okay, now we can just begin to set that in there and see what clearance we're going to need for the wire. Now, after looking at this, what I decided to do is just double up on the bushings, put one on the inner, one on the outer. And I'm not sure why, I just was getting a little nervous about having only 2 little bushings. When I go to adjust that horn, it may put some stress on them. And I just felt better about having the extra bushings on there. Now I need to pull this out, and I need to just relieve the back of the wing just enough for the 1/8 inch wire. Now what I wanted to do is just take a little sanding block and get in there and relieve this for the 1/8 inch wire and the bushings. And then what I want to do is just tack the bushings in place. Make sure I'm happy with the way everything rotates. It's handy that I have a center line where these wings join together to work off. In other words, I can't put the horn right on the trailing edge. It's got to sink down in roughly half of the diameter. Now what I did, I just put 1 small tack of thick CA, no thin. I don't want to take any chance that's going to bind up in there. And I want to make some little balsa wood, little horseshoes that go on the back of this, and then ultimately put some carbon fiber on there too. I could just take a piece of scrap here, put the little channel in, and once I have that thickness, once I have that shape, I can lop off little pieces, put it right on the back of the horn. Okay, the little horn retainers, they need to just be attached with thick CA. Again, I'm trying to keep thin CA for nowhere getting near that horn. Again, because of bad experiences I've had. Even if you oil that wire, which I've done, and some gets in there, boy is it a nightmare. Now one by one I can get them attached like this, and then the final thing will be to sand this into a little triangle shape, but it's easier to get them in place first as raw blocks. I got all those little blocks sanded in. I want to take some thin carbon fiber, the little flat stuff that we make the tank with, and just put a little strip on each piece, just as a cheap insurance that 5 years down the road, once that takes a lot of wear and tear and vibration, just cheap insurance to stiffen that up. Even though many times I've seen people do this and not stiffen it up in any way, I still sleep better. It's that thing of sleeping better at night. And also I realized I made myself a little problem here. Normally I like to have the push rod coming out and going through here. Well, what that would mean is this, when I offset this, I didn't take into account which side it was offset on. It should be offset to this side to do that. So rather than have the push rod run that extra angle, I'll just put the wire in the opposite way, even though I don't really like to do that. The reason is for it's my redundancy system. In other words, if the washer would in service fail, the centrifugal force, if the rod is facing this way, but I don't like having that angle in the push rod. And again, as I looked at this 100 times, I didn't realize it until the horn was all done, and I'm not going to make another one of these horns, that's for sure. It's a small thing, but the rod should in essence go out. The thing I wanted to do is just dress off this edge, get this edge on both sides. Because I want that carbon fiber to wrap right around. Now I'm just going to put on a few drops of thick CA here. Once one side dries, and I'll let that kick off without kicker, once one side dries, then I can flip it over. Once I can get tension on that, that's fine. Now, well, it's just a question, just as soon as I know that's dry, flip it over. Now I got that. I'm just going to take the slightest little bit of CA here. This really does add a lot of strength. I really, maybe I understated that, but we've been in the habit of doing this for a lot of years. If you didn't do this, double or triple tissue would certainly be another choice. And when I'm all done with this, I'll just wipe this with thick CA. Again, no thin CA down by that horn. First time that happens to anybody, they think, oh, I saw it on your video, and yeah, it happened to me. I had to cut the whole back off the wing. Oh. Whoa, hey, what's that all about? Now, I got to do that 4 times. We're ready to clean it up. I can always take a little, just a little piece of sandpaper, clean this up a little bit, put an extra coat of thick CA on it, and then I'm ready to attach the push rod in the way. Now obviously a lot of people like to use ball links. I'm kind of old school. I like the reliability and just the ease of getting everything in neutral when you have that little arrow shaft adjustment. And then I like the fact that it's permanent, that in the middle of a flight it doesn't come off. Now step 1, I want to make sure I've got this sanded relatively smooth. I don't have any binding in there. Nothing binding up, nothing's going to be a problem there. Now I want to set what I think is going to be close to neutral, because I need to know how much of that arrow shaft I need to trim off. I need to get a rough number, so I need to know pretty much where neutral is. Now let me just make a suggestion. If you're going to use ball links for any reason, and certainly you can do them. I hate that it sounds like I'm anti-ball link or something. But it's only because I've seen people use the wrong ball link, not set them properly, or have the ends pull out of the arrow shafts or something, that it makes me sad to see a good plane lost because of one of those things. So if you're not going to do old school, and if the advantage of old school is I'll have an infinite adjustment here. I can get neutral to neutral, neutral extremely easily, and then when I lock it in, it's locked forever. Forever. There's never going to be a time when a thread loosens up or something. So, but it's my logic. It's not a contest, and it's not a thing of, if you're going to use the ball links, again, get the best, latest stuff. Check with Noel Drindak, Rich Oliver, Tom Morris. These people have done it. Don't use the old stuff, the little clevises and little things that I'm not sure, but years ago, boy, planes would just go in left and right. Gene Martin's plane went in, Ted Fancher's plane, among others, and because they didn't have the right stuff. I think they have the right stuff now, but I'm still an old school guy. And this way works for me. And as a bonus, it's just a tad lighter than the other way. Now again, step one, I need to know how much I'm going to trim off of this. So I lay a little piece of tape on this. I know I have to account for the arrow shaft end. So if I put this in relative neutral, again, right now we're not fine-tuning it. That's as far forward as things go. So I know I still have to take off at least when I'm in neutral, and I can look in at the bell crank right now. I'm kind of in neutral right now. I need to take this off approximately right here. So I can get a zona saw out and trim the arrow shaft. Now this step is really like overkill, but because I know people that have had arrow shaft ends come out. Two things can happen with an arrow shaft end. You can split by not wrapping this. This can split and it usually happens years into having a plane. Another thing, there's always a little bit of an agent on the inside of the arrow shaft, and that's what I'm doing. This is from Bernie Trent, these little sanding sticks, or you can make your own. I guess you could just saw up a Bud McKnight standing stick, but by getting in there, getting rid of that agent that's in there, now you got a much better chance the glue is going to grip. Now that we have this, now I have the length right, now I can pretty much say here's so now I know between these two lines is my neutral, relative neutral. Now the next step is to make the arrow shaft end up with the little piece of wire. Now I try to find, and I keep a couple of extra ones in the bag all the time, ones that have, because they give you 5 with an arrow shaft kit. Here's one. I don't want the ones with the 2 holes. With the 1 hole, I need to drill this out so it's a nice tight fit on an 093 wire. Now the next step after I bend the wire, I have to trim this off so just enough of it sticks up over the arrow shaft. Before I ever even bend this wire, I have to have this bend made, because I'm going to set everything in neutral and then figure out where that bend is going to be. Then I'm going to elongate this hole just enough that I can get it in perfect neutral, tack it 1 drop of glue, wrap it with carbon fiber, make sure I've got perfect neutral, and then solder the washer. This is really and I think this came right off the Magnum kit. I'm not sure Mike Pratt, I'm trying to figure maybe Mike Pratt invented this, I don't know, but it's been a way that has really allowed me to get a nice fine tune on everything. And the secret is that once this is installed, getting that little elongated hole and then wrapping a whole end with carbon fiber. So the next thing is I can mark on the arrow shaft roughly where this hole is going to go. I want to allow a little bit of extra room front and back. If I need more than than let's say 1/16 of an inch, then I'll just bend another piece of wire. But what this is going to allow me to do is infinitely set this wire back and forth and then lock it in place forever. Okay, so I have that little elongated hole there for the little piece of wire to stick up through. Now with it all set in place like this, what I still have is this little fine adjustment back and forth. So now what I need to do is set everything into neutral, estimate where to bend this wire, put a 90-degree bend in it, then I'll do all my fine tuning up here. And then I'll set this with thick CA, wrap the whole thing with carbon fiber. And at any step along the way, if I want to adjust neutral, even if I screw up this wire, I can just make another wire. Until I lock it in, totally lock it in, I'm pretty safe. It's the only time this gets to be high risk. Once you lock this in, then you kind of have to re-engineer everything. But as long as you just tack it, you can always just pull that wire out and start all over again. So now I know I have, let's get this right into neutral. There's neutral. This is right at neutral also. And I can take a little piece of tape. I don't have to get this super accurate. I just need to be within 1/16 of an inch. If I put that bend on there, now I can take this piece out. In the very front of the adjustment here, just to do my first adjustment, I put a little trough for a wire, a safety wire, especially with this wire going in the reverse direction. So the first thing I want to do is with this set right here, I can stick a toothpick in there for right now and see if I need more up or more down. I should be pretty close, but it's very easy to figure. If you make it a little bit longer, you'll have more of one side, a little bit shorter, and a lot of times you hit it right in the middle. So the test is to see, and if you have to, there's an easy way to do this. Just put a piece of paper up there and see which way you have more degrees of travel. But for all practical purposes, you can just do it by eye. It looks like we're pretty close. So now we can lock that in, but if we wanted to move it, we just could move the toothpick, take the toothpick out, slide that up and down. But once we lock it in, then pretty much we have our, well, hopefully have it forever. There should be nothing that loosens up there or nothing that gives you a problem a year later. Now here's one thing that could be better. When Dave or whoever put this hole in here, and I'm not sure, doesn't matter, we're not trying to play the blame game, but this hole, this piece of wood could have been further down. In fact, it could be down a little bit more even. It's not a critical thing, but it could be that this hole itself, so what I'm doing, I'm losing, let me just get a piece out of here. I want to get some of this. And I'll clean up the edge of the hole. Where this hole is, it can be as far back as you want, because back here, nothing's happening back here. The place where this wing is under stress is right here. Now luckily for us, it's not a big deal. This is not going to break. But it would be nice if we didn't have that hole that far forward. So what I'm thinking next year when we cut these, we'll measure one of the wings that's finished, make a template, and not have to deal with having this hole so far back. Just a small detail improvement. Now I'm just going to make sure nothing's rubbing, that I got perfect clearance around this. I don't want that push rod touching anything. Now to be honest, what happened when Les was laying out a smaller wing with a ball link, the push rod got so high that we almost had this notch coming out to the high point of the wing, which I think isn't a good thing. In other words, we'd like to have as much of this uninterrupted sheeting as possible. We really did cut that hole too far forward, but again, that's This is how you learn about these things. Now I can just get rid of that push rod for now. Trim this off a little bit, but knowing that how this is going to work, I'm going to make a pattern for next year's plane. And once you cut it here, it doesn't matter how big you make this hole. You can make a hole, a gigantic hole, because the stress of this wing is right up here. Just one more little detail we could do next year just to make them a little better. I did. I put some tape along the edge so I could get a nice neat edge here. I'm going to seal this edge with thin CA because I don't, while the push rod's not in place, I don't want to have anything get in there and cause delamination. And actually what I'm going to do, I was thinking of this, because this is so far forward, I'm going to put a little piece of carbon fiber right up here just as a, so a stress crack doesn't start there. I'm just a little skeptical. I think we really did cut that hole way too far forward. And there's no reasonable way to patch it right now. This is a handy thing. Take an ink marker with some sticky back paper. Now when I take this tape up, I should have relatively workmanlike. Now I'm looking at this once it's in and trying to figure out, hey, this will be a difficult thing to figure out, how far down that hole actually has to go. It's rubbing there. It can go to roughly there. And you know what? It bothers me enough that I'm gonna, and I don't know, I don't think this is really necessary, but it's probably overkill. But what I'm gonna do is put a piece of 16th balsa in there, and then carbon fiber over it, or glass over it, or whatever. I just don't like the idea. That hole is right in the middle of the wing. Boy, that's... I'm just going to try to freehand up a piece that'll fit in there. So let's see what diameter this turns out to be. If we go with 7/8, I'm trying to fit this piece in by carefully, and it's a little tight on that side. This is just going to require a little bit of hand fitting, a little bit of sheetrock work here. And I know this is overkill, but you know what? If you're wrong, nothing bad's going to happen. If you're wrong the other way, that's the way I always try to evaluate a decision that's hard to make. If I'm wrong the other way, what really happens? Now, rather than carbon fibering over that, what I thought I'd do, I'll trim this for the push rod, of course, with the Dremel tool. I'm going to harden this up with thin CA, a couple of coats, and when I tissue this, I'll just double tissue the whole middle of the wing going that way as an alternative way of doing this. I just didn't want to have... a lot of times what happens when you have a place like this, there's a stress riser right here. And that stress eventually in time starts a crack, just like in a connecting rod in a car. And then it works its way up and eventually the wing fails in service. So, and I'm assuming Rich Oliver and Dave, the other two people and Les, that are working on these right now, you'll want to seal this up. Now with a ball link, this hole gets bigger. That's another, I didn't even take that into account, but I think that was well worth it. I'm going to trim that off. I'll definitely sleep better tonight. And sometimes it's these little things that let a plane last 10 and 15 years instead of 1 and 2 years. And of course I want to seal that whole edge. Again, I'm going to redo the whole thing with all of the sanded edges and then seal that all with thin CA. Again, one of my goals here is to make a plane that'll last forever. And the minute you have one failure in a plane, especially a control system or something here that in the center of the wing, that can be a problem. Now, the final thing, make sure we haven't altered this in any way. We've got the same amount up, same amount down, but I still don't want to make a permanent. I want to lock it in with a little thin CA here. And I'll cut off the toothpick. Let that wick its way down in there. And we can cut the toothpick off. Again, then recheck, because you just, at this point in time, we're not really committed here. We could still change it. Once I wrap this, then we have to major surgery to change it. It looks like we got neutral right about where we want it. Now, plenty of glue up around that wire and the toothpick. I want to roughen this up, get ready to wrap it with some carbon fiber tow. Again, if anybody doesn't have any of this, it's something I use on an everyday basis. Don't go out and spend $350 for a roll when all you need is a foot or two. I like to roughen up the arrow shaft. And this is how it comes on a roll, and you can use about a foot to wrap the end of an arrow shaft. And what I do is I just get it tacked down first, one drop. I don't want to get too much on there, just a drop. Now it's just, once I get one layer or two layers on there, then I want to hit it with some thin CA. Because the most important thing is to reinforce it where that wire comes through. Once I get one wrap on there, you can just hold this. It just takes one drop. Once that, then I can wrap it right down again, wrap it back, all the way to front, all the way to back, CA it, and I'm done. And I just got to solder the washer and make sure we haven't put any bind in anything. Now here's another useful one of these undersized washers. The idea of the undersized washer is you drill it with a precision drill, in this case an 093, and it's a kind of a press fit on the wire. What that does, it doesn't let solder wick underneath and mess up your horn bushing. Now also I have that little notch in there for the safety wire. So, and again, if you need any of these, just let me know, because we have eyelets. We could be in the eyelet business. I want that wire to be in the notch, so even if this and that's always the problem with when you have a loose washer, the solder wicks underneath it. This was really getting me nervous. I thought that wicked in there. But even if it does, you can just reheat it. I don't want it wicked in there though. Just move that till it cools down. Deflux it with the baking soda and we're ready. This has been a hell of a day. And of course the most important step, baking soda and water. Deflux every joint. Now I was doing this every step of the way, making a horn, because the flux that you use on Stay Bright is sulfuric acid. You really have to neutralize it. And I'll just rub a piece of sandpaper there's a little razor spot where the wire was sticking out of the solder. That's about one of the nicest installations I've ever made. I'm glad we covered this up, took care of that little issue. We got perfectly free movement. Now I don't want to oil anything here or put any chain lube or anything on it, even down here, until we get some of this, well, we got to get the other piece soldered in here. And I don't want to get any, I want to get dope down in between here to seal that up. Anyway, that's really good. Next time we get to work on this, I'm thinking, I'm looking over at the wall there and I see the flaps made last year, Elliot made. If we don't find any better wood, we're just going to use his flaps. Anyway, another good day, and we're moving right along here with this. Now it's funny, every time I have a conversation with Joe, and he's about as psyched as I've ever known him in all the years that we've worked together, I keep thinking about that big 90 Spitfire. And I'll bet you any money he's thinking about it even more than I am. And I've said this before, here's what can change. In the last 10 years, what's changed? This prop, and this is the prop we flew at the Nats, this prop could now be a 14-inch prop. This is probably the first canopy mold we ever made. One of the first canopy molds anyway. And I look back and I think now we can mold any canopy. You know, Dave has gotten the technology of that down pat. These are the first little set of exhaust stacks we made. I remember making them. Well, now we have 3 different sizes and shapes of exhaust stack. So the 10 years that have come and gone, they're going to open up a window of opportunity for us to really make something special. And the point is, even though we're still in the middle of making the other plane, the 90 ship, we're going to try to learn everything we can from the 90 ship to put into this new Spitfire project. Now we know, for instance, just one of the things. All of the stab and elevators we made on these were flat 1/2 inch. Well, we know the one on the I-beam Spitfire that has the carbon fiber shell, that one's going to be maybe a little bit better, maybe a little more scale. We know even if Joe decides or I decide to do one of these up as a late model Spit, we can even do this kind of a canopy. We still have the mold. So it gives me a lot of things to think about beside the work that I have in the shop for that particular day. And I think to me, it's going to be the fact that, well, here's what I'm saying. The fact that we're starting this project basically a year ahead of time, I think is just going to make it even more exciting, because when it comes, by the time it comes to start making up the fuselages and the molds and things for this project, we're already going to have a mind's eye view of what we want, and I think it's just going to be, I mean, I think these planes are at another level. These are really at the top level of all the semi-scale planes that I've ever built. But I think the next ones are going to be even better. And I can just picture Griffin blisters, big stacks, canopies, detailing. And that's what, well, anyway, I just thought I'd share that minute of the phone call that I just had with Joe. He is stoked, and I am so happy because I'm stoked too. Now we also have another thing coming, and spoke with Doran late tonight. Doran is going to be sending me a set of prop molds so I can mold up some 90 size props, some 4-blade props. And I wanted Doran to shoot some video of how he actually is making a prop, so I could suggest maybe some ways might make it easier for him or better or whatever. But because we've used his props for so long, I wanted to in-house make a whole bunch of them and see if I could make them a little bit thicker, a little bit thinner, whatever I could do to add my knowledge to what Doran has already developed. And I think by next year, just one other final thing, by next year we're going to have even better props than we have right now. See, everything gets better. That's what I like about working in the world of modeling. It's like automobiles. New automobiles don't need tune-ups and oil changes every 10 miles, and tires don't wear out in 10,000 miles and stuff. Modern cars, modern airplanes, just gets better and better and better. And actually, it was pretty good back then, but I think it's even going to be better.
And the biggest thing of all is just the fact working with Joe has always been so enjoyable. So much fun doing our build-a-thon weekends, and we've added Rich's Stuka to that project now. I remember the days with Brian Kiefer, old Brian Kiefer here. We used to do those Monday night building sessions. Well, my vision is that this whole next flying season, and then that build, I'm actually, in my mind, I'm already building this 90 size Spitfire. So it's really got me thinking. It really got me excited. And I love the shape of those Spitfire wings. So for whatever those little thoughts are worth, give you something to think about too.
And at night when it's too cold and dark to fly, it's never too cold and dark to take a flight on the KW.
Now this morning I wanted to get up really early. I wanted to try to get some flaps set up because Rich Jacobone's going to come over in the afternoon and we're going to try to sand out and glass the joints on his wings. So I wanted to get a nice early start. Now what I was hoping I would be able to do is get some really good 3/8 C grain because I wanted to make 3/8 flaps. I didn't want to make built-up flaps, but you know what? This is one of those things where reality sets in. The wood that I have that's 3/8 is not C grain, and it's certainly not good quality wood. So
The choice was, and I thought about this all night, I was thinking I have the spare set of flaps that Elliott made last year that are good, and they worked out well on this wing, so maybe I'm just getting too cute. So what I decided to do is see if I can work on those flaps today. What I need to do, and I want to get this done before Rich gets here, I want to get the little horn tubes made. See, there's a way of that I've done all these things, and I just get into a logical way of doing them. I put the tubes for the horns on the end of the flaps once they're carved, and I think most of the carving's done. Then I need to lay them out and set the hinge pockets up. And then most of all, I need to really pay attention to getting the tips sanded exactly the way I want them. And again, that was one of the things on a Testarossa that was a lot of work getting it nice and even and getting that flow where it goes right out to the wingtip, because I think that's part of the design, part of the look that I'm looking for. So let me see how this is going to lay out. Now these are the ones Elliott made at last year's Build-A-thon. Actually, they're not bad at all. I wanted to see if I have a true trailing edge. Trailing edge looks pretty good. That looks pretty decent. Now one of them has the notch carved in it. I can do that. I took the heavier one. It's only 1 gram heavier. That'll be the outer one. I'll work on the outer one first. So the first step is I have to get the notch in, the V, whatever we want to call that, the taper. And I'll do that the traditional way that we always work on flaps. Actually, I got one done. And these look pretty nice. Elliott did a nice job on these. So on the one that is not angled off yet, first thing is to get a center line down there. If it's difficult to do this just with the edge of your hand the way I'm doing it, you can always lay it out with 1/8 inch tape. Then I need to get a couple of pieces of 1/8 inch tape. And I want to thank Elliott for making this extra set, because right now, and I don't know why, trying to get sea-grain wood is like really pulling teeth. And I'm not so sure. Maybe it's not even going to be a problem. That I wanted to try using 3/8 flaps, but it's not a deal breaker if I can't get the wood. We'll go with 1/4 inch. We've never really had a problem with 1/4 inch, so maybe it's just overkill. I have the 3/8. I don't know. So it's ordinary 1/8 inch tape. I have the center line there. I know Rich is excited as can be. He calls me every day. Joe's calling every day. Rich Oliver's calling every day. Boy, this is probably the most exciting time I can ever remember. There's more people doing more interesting things all at the same time. John Cafaro's already got the first Miss Ashley belly pan in the mold. We'll find out how he's doing with that. Gerald Shamp's anticipating a Bearcat with a Rojet 90. I don't think you could find a better project than that. That is really cool. Okay, now when I have the 2 layers of tape on, then I take the first one off, and that's my guide. Now from that corner to here, that's my angle to work off when I carve this side. And all I can do, and the way I like to do this, to get the first cuts off, hold the knife 45 degrees, number 26 blade. Just take some of the material off. When it's sea grain, the knife tends to take a little bite, so I try to take very small pieces off and do the last little bit with a sanding block. Try not to get too carried away, because I don't want to gouge in any further than I have to. Now there's always this big debate about are 3/8 flaps necessary? Are the stiffer flaps better? Well, no, it's all yet to be proven, but we know the Testarossa flew pretty good with the ones Elliott made last year, so not gonna lose any sleep over having 1/4 inch flaps. Okay, now the last little bit of that I can dress off with a sanding block over by the dust bench. And using a sanding block, I can get the last little bit off. You actually can feel when you're touching that tape. I can anyway. Then of course, that's pretty good. Once I have this side done, I'll just repeat the whole thing and do the other side. Now I've always had a sequence that I do this in, and it's real simple in the fact that before you do anything, this horn has to, I make sure these two are parallel. Even though I have an adjuster, I want them parallel. I want to make sure this hinge line is true and that my horn is 90 degrees exactly, and it is. I want to also make sure when I go to put this flap on that I don't have an angle here. I don't want this angle coming back or forward, because that's going to go right up against the fuselage side, and that's pretty straight now. So you would think, having given that'll be straight, and it is. Now the next step for me is I've got to get the aluminum tube. I'm going to put an aluminum tube in here just a little bit longer than the horn and sink it into the edge of the flap. See, here's the problem that I ran into years ago is I would go put the flap on, put the hinges in, or carve the tip in, and then come over here and do this, and then there'd always be a space or a gap or it wouldn't fit. If you start at the middle and work your way out, and the last thing, the absolute last thing, blend the tip in after this is already confined. Just makes it easier. And that's a method that's worked pretty well for me. Now what I do is the horn is going to end here. I want to extend the tubes a little further back, and this is just a random place. I picked halfway between where the horn ended, and of course this is going to get thicker than a flap here. It's not going to serve any purpose. So right about where this gets as thick as the flap, that's about how far I'm going to go out on it. Now one of the things, this is always an area, if you don't have a horn adjuster and you go to tweak the flap, it breaks right here, or worse, right where the wire ends. So we want to kind of stagger the joints so there's no one place where this wants to break, just in case, say, somebody's wiping off the plane and they put a little stress on it. You don't want to crack that. So I'm going to do a couple other things in the course of building the plane to make sure. This is one of the things I really should have beefed up on the Testarossas. I should have put some fiberglass there or whatever. Of course, it did crack eventually. I had a crack in the paint from fooling with the flaps. Okay, the next thing is the tubes. And I cut the two aluminum tubes. And what I'm trying to do is a lot of little upgrades. And with a blade, skim the inside out. Put a little bit of a flute angle on it. Then I need to seal up the side. I found this to be a great tip. The horn is going to go in this end, but what happens if you leave this open when you CA this? CA gets in here and you have a giant mess. You got to get in there with a file or a hand drill or something and get it out. So I'm just going to seal the end of the tube on this side with a piece of thin balsa wood. Now because these ends are relatively sharp still, I can just cut me a piece. This is just scrap balsa, and what that does, that just one drop here. We could seal this up. So when I put this in place, I don't have to deal with, I also have to scuff this tube up so that the glue is going to stick to it better. Scuffing a tube is very important. Otherwise you're not going to get a good grip on with any glue that goes in there. Now the side that faces the wire, we need to put a little bit of and I know what it looks like ahead of time, so I can just do it with a Dremel tool. Just put a little bit of a notch in here so that when this slides in, the curve in the wire, it doesn't have an interference fit. And good that end is sealed now, because in the past I've had CA wick in there and oh, you're drilling it out and then this gets sloppy, and just this is a good little tip. Now this is the little fluted area that allows, when I slide that on, it allows for that curve in the metal. Now I could put this right now. I could put a little bit of the the taper in here. Before I even start, I can get rid of some of this material just to make this a little bit easier and not put a dent in the trailing edge. And this will follow the contour of the final flap fit. So in essence, it almost looks like a little bayonet. And again, getting this nice, a smooth fit. Now I want to put a little recess in here so that that aluminum tube is going to sit into a kind of a little recess. And by using a new blade, I can kind of get some of the material out, and in the last little bit I'll make up a little sanding block. Now I have a piece of 1/8 inch wire and some sticky back paper just to get this as well as I can. Get a notch. I really want to just confine about half of it. And I want to maintain that it's parallel to that 90-degree edge. I don't want this to go in skewed one way or another or skewed this way. So I'm going to take my time and get that little notch cut right in there. Now I didn't plan on doing it, but the horn just fit right in there, totally parallel. And what I did, I got a couple of swipes of the sandbag block on there while it was tacked in. And it was perfectly straight, believe it or not. That's unusual, by the way, especially for me. So I want to seal this whole end, and this is why I need that end. I'm just going to let that sit. And once I get the shape, I want to harden up all the wood, because of course the wood is paper thin up here until we glass it or tissue it or whatever. But it's amazing how quickly the thin CA hardens that right up. Now the two things I have to do is make sure that I haven't altered the 90-degree angle here, because if that tube is in even a little bit crooked, it's going to alter it. I also see I left a little bit sticking out here. And now I just need to trim that flat. I can do that with a sanding block. And then I want to cap the end of this off. Now the cap is going to serve two purposes. I want to add a little strength here, the whole length of this. I don't want to have this end, and I'm going to try to end it on a piece of 64th plywood, so I'll have a nice flat edge for whatever I want to do with the rest of it. But it'll act as a rib with the strength going in that direction. Now this is one way of getting a nice true edge on this. Here's my big sandpaper. I'm going to take some rough paper. This is just a scrap of 64th plywood, grain going front to back. I want to create some dust on it. This is a good way to get a nice edge. Now you leave the dust on there. And I'm putting plenty of CA on there. Let it ooze out wherever it wants now. Now, I don't want to use kicker on that because I don't want it to all bubble up and everything and make me a mess. I want to have a relatively nice seam around here if I can. But that should give me the equivalent of a rib going down the edge. And if I put a little fiberglass or double tissue there, that'll be another nice little upgrade over the Testarossa once that kicks. Now once that dries, I get a brand new blade, trim around the edge here, or best you can even do it with a scissor. Block sand that in. That gives me a nice rib. I've got a nice horn mount. It's still at 90 degrees, that's exactly how I wanted it. and I hope I've got the strength here because this is on edge, and I'm going to harden this up with thin CA. Either glass it, double tissue it, whatever, because I know inevitably this takes a lot of load right here. Now that last little bit I'll do with a sanding block, but again, once I get it nice and flat, running some thin CA on there and building up a nice hard edge, that should just add a lot of strength without adding any kind of extra work into the finish here, because once this is block sanded out, you can always bury a layer of fiberglass or the double tissue or whatever. But that really added a nice edge, and I was originally going to set the tube halfway in and then put a rib here, and the way it just went right into the wood, nice and neat. Just a little nicer, neater way to do it, and we don't have any CA in there. This slides right on the horn. I've maintained my 90, so right now it's all things good for this flap. Now before I go to the next step on doing the hinge pockets, the next step would be, of course, verify that everything here is okay. Then I need to lay out the hinge pockets. And the tip, but what I wanted to do is, because I'm getting into a little rhythm here before Rich comes over, I'll just work on the next flap and I'll go from this step to this step to this step. And if I have to stop in the middle of it because the session ends, it won't be a problem. But we're coming up on a point where this is starting to really be an aeroplane, and I'm looking forward to that day that we carve up the top block, start putting the scoops in the fuselage, and it's coming. It's coming like a freight train. Now the other step is just going to be redundant. I'll do that off camera, then come back to this once we're ready to lay out the hinge pockets. So every step of this, from the way the horn was laid out to the way it's going together here, pretty much every step of this has worked out pretty well. And maybe we're better off without. And again, if I didn't have the performance that I had with this plane, I'd be thinking there's a gain to be had, but maybe I'm getting ahead of myself here. I have to constantly remind myself this plane exceeded all my expectations, and this one I just want to even be better. Now when I'm done with this, I always make a final adjustment. I take a drill and by hand just make sure that I haven't gotten any CA down in there, because what happens when you force it on, then it's a Chinese necklace and it's hard to get it off. But just a few swipes with the edges of a drill, and never take a drill here and just bzzz and run it with the motor running. Found that out the hard way, of course. What I'm looking for is a nice tight fit, but not so tight that I can't get this part on and off to do the rest of my fittings. That's just about perfect. Now the next thing is, I want to look at this from the edge and make sure I have a good flap alignment before I line up the hinges. Okay, that's lined up pretty well. Now with the hinges in place, I can just mark out where I'm going to need to put hinge pockets. And we've got a nice tool for doing this. So the things that we set in the mold, those positions, and the extra one at the tip, all I need to do now is just cut the hinge pockets and put a slot in there for the hinges. Okay, so we have all our little marks where we're going to need the hinge pockets. And we have that little tool, that's the thickness of the hinge. In fact, the sandpaper is coming off here. Maybe I ought to get my money back. I don't think so. I can line it up with the little lines. And I've got a hinge pocket that, I'll take a hinge out here. It's basically the thickness of the barrel. And I could just go down now and set all the hinge pockets in place. Now I want to put the center line back on where the hinge pockets are. And we've had so many different ways of cutting the hinge pockets in. I had the little jig from Bob Martens that worked well. But one of the ways that still works well is just to do it with a knife. As long as you're working off a center line, and make up the little blade to pull out the extra wood. Les had bought this little thing that set everything in neutral. That was pretty good. Really no contest. There's plenty of good ways to do this. But the most important thing is to start off with that center line. Now I got this old greasy tool that has a bunch of notches and nasty teeth on it. And once I put a slit in there, then I can get in and just dig out just enough material. This is a clearance thing. And of course you could cut this with a parting wheel, cut it with a knife, doesn't matter. Because if the hinge is a loose fit, I don't really care. If I turn this over and it falls out, that'll fill with epoxy, and we're gonna put scores on this that'll make it just a little bit thicker. But what I don't want to have, I'd like to have just a nice press fit. What I don't want to have is that when I push this in, this part of the wood goes and swells up. So I have this, I don't know, I've used this for so long. See, and this just helps gouge out just enough material and I can work it. So I've got that, and when it's in there, then I want to run my hand over here and make sure I haven't swelled that up. I'll get all these hinges put. It looks like we're going to have a real nice fit here. All of these are fitting real nice. Usually by now I can tell if everything's going to line up just nice.
Sticky back.
Now where did you get these? From Chard?
Yes.
Hey, Rich is here. He's got Sticky Back 220. We're going to try to...
These are the ones that I bought originally. These are the ones that I just bought.
Oh, well, it doesn't matter, as long as it's 220.
It's a different brand.
Yeah.
Than this.
But what we got to do now, the next step on the Stuka wing, is where these joints are at least 6 inches out on each side, we got to get this perfectly smooth for 2 reasons. We have to get a grit on this so that the glass is going to stick in the epoxy. And we're just going to basically try to do this, just the joints today, because then Rich can take it home and sand the rest of the wing. And he's going to have to blend this in anyway. So the biggest problem here is we do not want to sand and thin this out. Now on this side it's not critical, but Rich, when it's a high spot, when you got a mountaintop like this, and you're sanding with a block, here's the one thing you never want to do is have it this way. You see what I'm saying? It can be this way, it can be this way, but you don't sand the joint. You follow the logic of that?
I understand.
Okay, so
take this and
right,
thin it out.
if you thin this out, we're dead.
Then we don't have any more
Exactly.
material.
So let's pick, I guess the easiest one is one of these. Let's get some of those sanding blocks set up, and let's see what this is going to sand out like.
Is this the way you would like this?
However you can do it, doesn't matter. You're going to have to use a block for everything on this.
You want to cut this, don't you?
And we got to get, well, now when you're sanding, just remember, we don't want to make this paper thin, right? Even at the point of leaving it a little lumpy, but you don't want to cut through the fiberglass that's already on there. Now we got to get, let's do one joint at a time. Let's do this one. In other words, keep that flat, and then when you work this side, keep that flat. But don't at any point lay it down. And it's going to take time. When you're sanding fiberglass, it's not like sanding balsa. It takes time. Now, while you're doing some of this, I want to look at the leading edge. See, the leading edge has a joint. I got to work that joint down. And then where we go through on that, I got to put some thick CA. And the only thing you can do when you got this much sanding to do is just take your time, because it's not going to go quick. And we'll keep the vacuum going. Let all the dust that comes off go onto these towels, and I'll throw them in the wash. I already did a load of wash today. And what we found out after a little while of working with this 220 sticky back. Working a lot better than the gray, right?
Oh, yeah.
The gray stuff, even though, see now, even this says 220. This is Sunbrand. Who knows what that is? I don't even know. This isn't cutting. And see how nice that's powdering off? Oh, that's nice. Okay, now just do it nice and careful. The problem you have is like when guys used to do a normal foam wing and they'd cut that center down. Oh.
No, even I know that.
All right. Well, it's not a question of knowing it. Is just not doing it to the point where you have a structural failure. All right, let me get a block set up. I'll give you a hand with this.
Why don't you give me a hand?
Because you're not paying me.
Yeah.
Where's my bagels? I thought you were bringing bagels today.
No, you told me I don't eat bagels
Listen to
anymore.
this, listen to this. What, I stopped eating because you're here? Keep that dust, see all the dust that comes off of there? I don't want to be breathing that in. That's definitely no good to be breathing.
Oh, no.
That's fiberglass dust. That'll make you itch and everything. Keep it neat, baby.
This side is done. You got to move this side.
It's inevitable that we're going to sand through some little spots like this where the high spots are on that joint. And right there, now we're going to do the old trick, put some thick CA on there and resand them. Because I want to get this as smooth as possible, we're going to put layers of glass right at those joints. You're making my teeth hurt with that noise. Can't you sand quieter?
No.
God. Okay, now the next step on this is basically sanded out about 3 or 4 inches on each side. Several times, this is probably the 4th or the 5th time we've done it. I want to run the thick CA right down the seam. Take a clean paper towel. While Rich is working on the other side, we're trying to both get some time in on this. And this is going to have to be 7, 8, 9, 10 times until we get that this joint is totally, there we go, totally smooth as if there's no joint at all in it. And that's the test, is when that E-glass powders off. Rub your hand on that now, feel that. Beautiful. All right, but that's how the whole thing, and especially the leading edge too. We've got to do the same thing on the leading edge. You can see the leading edge is still pretty rough. And what we're doing is we're sanding for about 2 minutes, vacuuming, sand, vacuum, sand, vacuum. Yeah, when you get the feel that it's like that, beautiful. Then we'll be...
Check this out.
How's that side coming? All right, you're getting it. Now see, you broke through here. Let me just show this. Right here, we're down to raw wood. That's okay. We're going to do the same thing. Thick CA, coat after coat. Just keep blending it in. That won't be a problem. And where that's broken through, we're going to do the same thing. The CA, you basically have the shaping fine. It's the final, and this is going to need a lot more sanding. You're not even close here, but it's okay. This is okay. It's, if we get the joints done and we get those glass things on it, then you could do the whole rest of it sanded out in one shot. And you could do that even at your own shop. You don't even have to do it here unless you want to. And make sure you blend it all the way around. Do you know what I'm saying? There you go. Blend it right around, because then when we do the top, you want to blend it from the top around the back. There you go. This step, more than anything, takes time, because you're getting that nice scuff for the fiberglass that everything's going to stick when we do those joints, and the dope for the tissue. Now while Rich is still sanding away, I want to lay out my belt crank support. Now this serves 2 purposes. It acts like a little bit of a spar, so maybe we'll make this the next size bigger. Make it out of several layers of 64th plywood, and each one would be laminated in so it assumes that curve. And we can do that before we glass it. The glass can go right over the top. Now we made up a whole bunch of these pieces, but they're going to go through around the valley. As soon as Rich is done with his vacuum stuff here. Oh, he's knocking my vacuum over. No respect.
No respect.
No respect.
68.
Now you know we got to do this in. You got your.
Yeah, I'm going to hold this
Okay.
down.
When you see how nice this works out, you'll be impressed. The same way the B-25 was. Okay, get that down. Then you got to hold it. Just let it kick. Just keep pressing here. Get it to press down. Let me get a paper towel. I want a good joint on that part.
Oh, wait a minute. Let me use this. No.
No. Use a point. Get it on the joint. There you go. Let that one dry, then we'll put 3 more on top. And just leave some dust on there. So what we're going to do is put one piece after another on there. 3 pieces. And just leave the dust. Don't take the dust off when you do that. And we'll put the next one on. And get that piece on there. Put it on there and get it nice and straight. Just hold it down there. And leave the dust on there for the 3rd piece. The dust helps kick it off. Get it even. Now we got a tray. You dress that off, and then we'll put the cap on it. See, that acts a little bit like a spar too, holding the 2 pieces together.
It holds the wing together.
We'll just get that nice and clean in there. And we pretty much, like it or not, we're coming up on having one side of this wing done. Now the deal is we got to sand the other side, same way, exactly the same thing. Make the bell crank support and then we'll be ready to glass it.
Yesterday we had some rain, but all in all, I can't complain. Was it dusty on the trail?